Hello, my name is Zefanya Teguh with the honor PO with the student ID of 11302117, and today I'm going to demo my machine learning midterm project. So the first of all, we need to load the CSV file. This is the code with the file path based on my Google Colab here, and then we will read the CSV file here. And let's start running it first. Okay, it can successfully import the data, and then can actually successfully read the data here. Everything's all fine. And then we can continue to clean the data. For the clean data, first we make a copy of the original so that we have two data, the clean and the original one. And then after that, the df underscore clean or the copy of the original, we start cleaning it by dropping the first two columns, which is these two, because we don't need it. We also rename the blood type column for easy reference from blood space types with the class label and into blood underscore type like this. Okay, and then we also drop the columns that have 50% of missing values in the column. And then if there's any rows with the missing values too, we also drop them. And then you can see the clean data set now. Okay, here it is. Then after we clean the data, we can continue to the pre-processing. So first we separate the features in the label, and then after that we encode the categorical features. We also encode the target labels, which are blood types, and then we split the data. And in my case here, I use 60% of the data for training, 20% of data for validation, and 20% of the data for the test. And then we will also print the record counts of these three datas, the train, validation, and the test. Okay, and then we can see here that we have 597 data, 597 record for training set, 199 for validation, and 199 for testing. After we have done the pre-processing, we can continue on creating the model. So first, I've defined four models here: the random forest, SVM, KNN, and logistic regression. Then from that, we'll compare all those four models and we will see which one is the most accurate. As seen here, reducible stable, and then we show all four here. Let's try it. Okay, in here we can see that the most accurate model is KNN, and the second most accurate model is random forest. And in my case here, I don't use KNN as my model. I'll just use random forest because, in my opinion, KNN is not reliable enough to use as a prediction model. Okay, because we have already used random forest here. Sorry, because we already picked the random forest, then we can see that the accuracy for random forest is 29%. The F1 score is 28%. Let's try improving the performance or do a hyperparameter tuning. So this is the code for the hyperparameter tuning. First, we define the parameter grid for the tuning, and then we initialize the model, which is the random forest classifier. And then we will use grid search CV to improve the performance of the model. And let's try running it. Okay, after a bit of long time, you can see here, this is the value of the random forest model that is already tuned or with a performance improvement. You can see here that now the accuracy is increased from 29% to 0% with a 1% increase. But the F1 score from 28 to 26, okay? Okay, because we already know the value of the tune model performance, let's try comparing the two performance between the untuned and the tuned random forest model. This is the code. We will first define the untuned random forest, and then we'll continue to the tuned random forest, and then we will print the comparison between the two of those. And then we'll also create the confusion matrix so we can compare both of them side by side. Okay, now after running it, we can see for the untuned accuracy, like we said before, it was 29%, and then when it's tuned, it will become 30% with a 1% increase. Same with the F1 score. When it's untuned, it is 25%, while when it's tuned, it will increase to 26%. And then this is the confusion matrix for the untuned and the tuned random forest. So I think that's all that I can demo from this code. Thank you for the time.